Hello, welcome to Astronautics for Exploit. This is Dr. Ayenshola Ogundele. Cislunar Space Imaging Technologies for unlocking new space opportunities. The focus points are as follows: importance of cislunar space and cislunar space imaging technologies. Over the years, space has been explored to solve many problems on Earth, and at present it is becoming increasingly valuable. Nowadays, attentions are shifting to the use of cislunar space region based on various advantages it offers, such as presence of abundant natural and untapped resources. For example, water, helium-3, rare earth minerals, and regolith, and a region for eye surveillance capabilities. Several cislunar space imaging technologies have been designed for cislunar space region, a large volume of outer space that is underutilized. Examples are cislunar space on-orbit servicing, cislunar space transportation, lunar landers and rovers technology, lunar resource utilization technology, space-based manufacturing and assembly technology, Cislunar Habitats and Outposts technology, in-space fueling and power generation technology. Presently, cislunar space on-orbit servicing technologies are under development. The space-based technologies are aimed at performing in-orbit activities such as spacecraft inspection, rendezvous and docking operations, satellite position, orientation and operational status change, and a host of others. Cislunar space infrastructure and transportation system technologies are being developed to provide regular movement of people, cargo, and propellant among locations in cislunar space. Based on the expensive nature of launching materials to the cislunar space, in-situ resource utilization technologies are being developed. This is very important for the reduction of the cost of cislunar space exploration. The lunar soil natural resources such as oxygen, silicon, aluminium, calcium, iron, magnesium, and titanium are very useful to be used as building materials for the lunar structures and habitats. As a result, emerging technologies are being developed to extract those materials. Some private space companies such as Astrobotic are developing lunar landers and rovers imaging technologies to further advance human exploration of the cislunar space region. Importance of cislunar space. Cislunar space is very important because it offers natural and lucrative resources including water, helium-3, rare earth metals, and regolith. Establishing infrastructures in cislunar space will offer advantages such as increased surveillance capabilities of a currently unmonitored cislunar space zone. Spacecraft surveillance in cislunar orbit is shown in this picture. Cislunar space imaging technologies are on-orbit servicing, cislunar space transportation, lunar landers and rovers, in-space fueling and power generation, space-based manufacturing and assembly, lunar resource utilization technology, and cislunar habitats and outposts. On-orbiting servicing technology is aimed at extending the life of aging satellites by attaching a module to replace their propulsion systems. It refers to refueling or repairing of space satellites while in orbit. New commercial interest in on-orbit servicing of satellites is due to the decreased cost of launching commercial satellites and the rise of low orbit rather than geostationary satellites for which servicing costs less. Artist's illustration of Starship firing its engine while passing by the moon is shown in this picture. On-orbiting servicing, also referred to as autonomous or telerobotic servicing of a satellite by robotic spacecraft, can also be performed by human astronauts, such as repeated and regular servicing of the International Space Station. Various space companies are developing cislunar space on-orbit servicing technologies Example is Orbital ATK, which signed Intelsat as the first customer for its on-orbit servicing program for the extension of the life of aging satellites by attaching a module to replace their propulsion systems. The move from lunar orbit with planet Earth rising over the horizon taken on the Apollo 8 mission is shown in this picture. Cislunar Space Transportation Technology. Various emerging technologies of cislunar transportation infrastructure are being developed for efficiently shuttling people and cargo between Earth, the Moon, and other cislunar destinations using reusable space vehicles like the Fugan Centaur rocket. Cislunar Space Development Company, a space logistics company, is developing and providing technologies of transportation services in cislunar space, from low Earth orbit to the Moon surface and all points in between. Artist's illustration of Gateway Cislunar Space Station is shown in this picture. Various services provided by the Cislunar Space Transportation include orbit transfer for satellites, cargo and personnel transport to the Moon, water and propellant sales, vehicle docking, and spacecraft warehousing. Cislunar transportation architecture includes reusable out-of-orbit propellant and water carriers, all propulsive and aero-assisted space docks, moon shuttles, propellant depots, propellant and water space tankers, and personnel modules. Illustration of cislunar space is shown in this picture. Lunar Landers and Rovers Technologies. Lunar Landers and Rovers technology are being designed to enable exploration and commercial activity on the Moon. The Lunar Landers and Rovers are planned to be used for scientific research, resource extraction, and habitat construction. Cislunar mission concept is shown in this picture. Lunar Resource Utilization Technology. In-situ resource utilization is the harnessing of local natural resources at mission destinations, instead of taking all needed supplies from Earth to enhance the capabilities of human exploration. In a bid to reduce the cost of space, missions of extracting, processing, and utilizing lunar resources, such as water ice and rare metals, in-situ resource technologies are being developed. Artist's illustration of plans for a program to develop materials for building large structures in orbit and on the Moon is shown in this picture. Space-based manufacturing and assembly. Manufacturing and an assembly of spacecraft, habitats, and other infrastructure in cislunar space, reducing the need to launch heavy payloads from Earth and improving the feasibility of ambitious space projects, are factors propelling the desire to develop cislunar space technology, which will meet the need. Cislunar Space Station is shown in this picture. Presently, efforts are ongoing to construct human habitats and outposts throughout cislunar space, including the lunar surface and various lunar orbits, to support scientific research, resource extraction, tourism, and to serve as stepping stones for further exploration of the solar system. Orbital ATK is developing technology for cislunar habitat using Cygnus spacecraft. Artist's illustration of Gateway Cislunar Space Station is shown in this picture. In-space fueling and power generation technology is another cislunar space emerging technologies under development. Companies and government space agencies are developing technologies for in-space fueling and power generation, such as the advanced cryogenic EFOP stage, enabling long-duration missions and reducing the need for frequent resupply missions from the Earth. Solar and nuclear energy technologies that will help in harnessing solar energy and nuclear power for electricity generation in cislunar space are being worked on. Different phases of space exploration using International Space Station, operating in the lunar vicinity and leaving the Earth-Moon system and reaching Mars orbit is shown in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to Cislunar Space Emerging Technologies for Unlocking New Space Opportunities, presented by Dr. Ayoshola Ogundele, with the focus points Importance of Cislunar Space and Cislunar Space Emerging Technologies. Thank you.